Hi Year 11, Mr. Vinord here. In this video we're going to work through acids and bases, what they are. So let's start off by recapping some of our Year 10 knowledge. In Year 10 you hopefully would have learned that acids taste sour and bases taste bitter. The only reason we tell you about that is to show you that acids and bases are different. They are not the same thing, they have different properties. Another thing you might have learned about acids and bases is that acids are corrosive. That means if you left some acid onto metal, for example, it would corrode into the metal, it would eat away at it and slowly dissolve it. Bases feel soapy, so if you get some on your hands and rub it between your fingers, it will feel slippery and soapy. A lot of soaps are actually made with bases. Getting into the slightly more detailed chemistry side of things, you hopefully would have learned that acidic and basic substances contain different types of ions. They contain H+ and OH-. And it all depends on how much of each of those ions they contain as to whether the substance is actually acidic or basic. So acids contain lots and lots of H+ ions. Bases contain very few H+ ions, hardly any at all. And when it comes to OH-, acids contain very little OH-, and bases contain lots of it. So you can see any acidic substance is going to have lots and lots of H+ and very little OH-, whereas a basic solution is going to contain lots of OH- and very little H+. We'll come back to that shortly. You might have also heard of this term called pH. So you might have heard that pH of an acid is going to be less than 7 and the pH of a base is going to be greater than 7. The range of the pH scale goes between 0 and 14. Again, I'll show you that shortly. So that is definitely true. Acidic solutions do have a pH of less than 7. Basic solutions do have a pH of greater than 7. So that number 7 there, that magical number, if it's exactly 7, that solution is neutral, neither an acid nor a base. How can we test for acids and bases? Well, there's a type of indicator called litmus paper, which hopefully you've seen before. Litmus paper will turn red in acids, and litmus paper will turn blue in bases. Now, litmus paper is actually just paper soaked in a litmus indicator, and that indicator will either be red in acid or blue in base. So the paper is just sort of a physical way to hold that solution. The other way we can test for acids and bases is we can add the substance called universal indicator. Universal indicator is fantastic because it gives us more detail around the pH of the solution. So in acid, universal indicator will turn red, orange or yellow, even up to a yellowy green sort of colour. Whereas in bases, universal indicator will go blue or purple, all the way down to a bluey green sort of colour. And you can see here I have the universal indicator colour chart. You can see that on the left hand side a pH of 0 or even 1 or 2 sometimes is red, and all the way through to 14 on the right hand side is purple. 7 is neutral, and we sort of have a bluey colour here around 9 or 10 and a yellowy orange colour there around 2 or 3. So this is the colour that universal indicator will turn when placed into a solution depending on its pH. So if I had a solution and I added some universal indicator and it went this shade of blue, I could assume that the pH of that solution would be around about 10. That tells me that it's a base and that it's going to contain lots of OH- ions and very little H+. If I added some universal indicator to a solution and it was green, I could assume that that solution had a pH of 7 and it was neutral, meaning the H+ and OH- ions are equal in concentration. There is no more of one than the other. They are equal in concentration. If I added universal indicators to a solution and it turned red, I could assume the pH was 0 or 1. And there was lots and lots of H+ and very little OH-. So this universal indicator is a very helpful solution to determine the exact pH of a solution, or the approximate pH of a solution, and to help us with some information about what ions are going to be present in that solution. So what are some common acids and bases? Well, I've got a few here for us to look at. I'll just show all of them there. The 3 acids that you really need to be familiar with are HCl, HNO3 and H2SO4. That's hydrochloric acid, nitric acid and sulfuric acid. Now, first of all, there's something in common between all of their formulae that you can see here, and that is that they all start with an H. That's because acids, when they go into water, produce H+, so they have to have that H there, which becomes the H+ in water. You can see on the right-hand side here, I've got two common bases that you need to be familiar with, sodium hydroxide and potassium hydroxide. You can see they also have something in common, in that they both have OH. That's because bases, when they go into water, produce OH-. So that's a helpful little way to identify if you have an unknown substance, and you can see its formulae. If it starts with an H, it's likely that it could be an acid. If it ends in OH, it's likely that it could be a base. So those are the common acids and bases that you need to be familiar with. The other thing you can see about acids is that these groups here are all made of non-metals. So an acid is an H bonded to a non-metal or a non-metal group. Those are groups, they're polyatomic ions. It's an S with 4 O's and an N with 3 O's. So an acid is an H bonded to a non-metal or non-metal group. A base, as you can see over here, has to have that OH in it. And you can see that we've got these two things here. They are both metals. So a base is a metal with an OH. There are some other types of bases that we'll deal with in a later video, but those are the two common ones that we need to be familiar with for now. So let's just refer back to the pH scale and what that means in terms of ions. I find this next diagram very helpful. What we can see here is a diagram of the pH scale. Now this is a simplified approximation, it's not the real deal, but it's useful for explaining the concepts. You can see here that we have our pH scale along the bottom, 0, 7 and 14. Again, 7 is neutral, 14 is basic and 0 is acidic. This whole range here, anything between 0 and 6.99 is acidic. Anything between 7.01 and 14 is basic. Now what we can see here is the approximate ratio of ions to each other. So let's have a look first of all at pH 7, about there. You can see that at pH 7 we have the same amount of OH- as H+. That's because those two ions are equal in concentration in a neutral solution at pH 7. You can see here on the right hand side at pH 14, when we're in a basic solution like this, it is all OH- with a tiny little bit of H+ there. So in a basic solution, you have the vast majority of ions being OH- and a tiny little bit of H+. In an acidic solution, you have the vast majority of ions being H+, and a tiny little bit being OH-. So this can be quite a helpful way of understanding how the pH scale relates to the approximate concentration of ions in an acidic or basic solution. So if I tested the pH of an unknown solution and it came back that the pH was 10, I could say that it's around about there, which means that it's going to have much more OH- than H+. If the pH was 2, I could know that it's down there. And the H+ is going to be much higher than the OH-. So this diagram can be really helpful for understanding the concentration of ions present in the different pH solutions. I hope you found this helpful. In the next video we'll look at neutralization reactions.